Hello, my name is Brandon Mayer, and I'll be introducing a paper called HUGE-TPU, Huge Graph Embeddings using TPUs that will appear in KDD 2023. My collaborators on this project are Anton Sitsulin, Hendrik Fitchenberger, Jonathan Halcrow, and Brian Perosi. What are graph embeddings? First, graphs are a particular data structure that capture explicit relationships between entities. We see graphs a lot in industry. Network communication and transaction data can be represented as graphs and in practice can grow to millions or billions of entities with billions of relationships. Understanding the world by analyzing these large graphs is an important, fundamental, and impactful problem. A graph embedding is the process of mapping a graph or structured data into a continuous space that can preserve certain properties of the original graph. A graph embedding may allow us to reason about the underlying data and structure of a problem in a way that can result in a more computationally feasible approach to large-scale problems. DeepWalk is one such embedding algorithm. It is a fundamental graph mining algorithm with a lot of citations, but it's unclear if it can scale to graphs with billions of nodes, as it requires storing a potentially large embedding table. The algorithm is a spectral embedding technique that starts by sampling random walks and training a skipgram model similar to Word-to-Vec. Tensor processing units, also known as TPUs, are dedicated hardware designed for extreme ML throughput jobs. Each TPU core comes with high bandwidth memory and a dedicated device for accelerating sparse lookups that can be bootstrapped for storing and accessing large embedding tables that can be leveraged in conjunction with extremely high throughput compute units. Our paper explores scaling DeepWalk with pools of heterogeneous compute machines and specifically TPU systems. We demonstrate that it is possible to achieve enormous throughput and cost savings with superior performance using simple DeepWalk algorithm when accelerated with specialized TPU hardware. Thinking deeply about specialized hardware, their specific compute models, and how they can be leveraged to support scalable graph embeddings is important for industrial applications, and we hope our work will motivate other practitioners to consider hardware accelerators and develop novel algorithms that can exploit their specific properties. Thank you very much for your interest in HUGE-TPU. We will be making our code available on GitHub, which you can find using the QR code. We're looking forward to seeing you at KDD 2023.